Okay, so what we have here is we have this guy who's driving, he falls asleep, and he hits three guardrails. They're telling us what we know what the original velocity is when he falls asleep. So what we want to figure out is if I can figure out the change in velocity and I know his original velocity, then I can figure out his final velocity. So there are three impulses that are happening here. The first one, they're just telling you what the impulse is. There's no math to do for the first impulse. The second one, you have to use the idea that impulse equals force times time. So I can get the second impulse from those two numbers. And then the third impulse is we know that the car has a mass of 1,500 kilograms, and based on the third impulse, its velocity is going to be reduced by 3.2 meters per second. So we've got three things here. Now also, these three impulses are going to be negative because they're slowing the car down. So if I want to figure out the total J, the total impulse, I'm going to get this 5,700 Newton seconds. That was the resistive impulse, the first one. So I'm going to write that as negative 5,700 Newton seconds. Then to that, I'm going to add the second impulse, which is that number times that number, but this number has to be negative because, again, it's slowing it down. So the second one would be negative 79,000 newtons times 0.12 seconds. And then the third one, actually the third one, it's giving you the change in velocity. So you could exclude it from this equation for impulse and just subtract 3.2 from whatever the answer is with the first two. But I'm just going to include it because I do know the mass of the car and I know how much it's changed. So that by definition is an impulse. So I'm going to have 1,500 kilograms, and the velocity is reduced by 3.2 meters per second. So if you add all those up, that's going to give you your impulse, the total impulse that acts on the car over this time period. So what do you get when you add them all together? Let's see, I'll work it out too. So minus 5,700. I get negative 19,980. I guess if I were rounding that to three significant digits, that number would be negative 2.00 times 10 to the 1, 2, 3, 4. 10 to the 4. I can write it as in Newton seconds, or I can write it in kilogram meters per second. Since I'm solving for a final velocity, I'm actually going to write it as kilogram meters per second. So now that I know the J, I know that impulse equals change in momentum. So impulse also equals the mass times the change in velocity. I want to get the change in velocity. If I can get the change and I know the original, I can get the final. So solving this for the change in velocity, it's going to be the J divided by the M. So it's going to be 2.00 times 10 to the 4th kilogram meters per second. And we're going to divide that by 1,500 kilograms because that's the mass of the car. So if I take that number divide that by 1,500, I get 13.33 or 13.3. So 13.3 meters per second is the change in velocity. Well, we also know that change in velocity is the final velocity minus the original velocity. And I know what the original velocity is, and I'm looking for the final velocity. So if I move this term to the other side to solve for the final velocity, I'm going to get that the final velocity equals the original velocity plus the change in velocity. Yes? And actually, again, you're right, it is, this should be negative. So that's negative, which means that the change in velocity is negative. So, again, and put the negative in. I would have caught it down here, but because I know the final velocity is going to be less. So the final velocity is going to be the original velocity, which was, what was it? The original velocity was 19.8. So it's going to be 19.8 meters per second plus the change in velocity is negative 13.3 meters per second. So if we solve that, that looks like 6.5. 19.8 minus 13.3 is 6.5 meters per second. Not three. I didn't write it to three significant digits. These numbers were to three significant digits, but that's what I get. Any questions? Okay, so that was an impulse problem.